Hello, everyone. Thank you for joining us today. Good morning, good afternoon, good evening for everyone, like wherever you are from. Uh, my name is Avinash Desiredi, Senior Solutions Architect from Mirantis. Joining me today, Connor Williams, like DevOps Engineer at Mirantis. Connor will be sharing insight into how to accelerate your application delivery process on top of Kubernetes using DevOps Care, which is powered by Lens. Uh, Throughout the session, you can use the Q&A section on the right side of the screen uh, to post any questions, and we'll be proactively answering them. And we'll have like some time at the end to answer any other questions in live. And with that, I'm going to hand it over to Connor to take it forward. Uh, Connor, please.
Yeah, for sure. I'm Connor Wilhelm. I've been employed at Mirantis for around 4 months now. I'm a DevOps engineer on the DevOps Care team, and I'm just going to be talking to you about how we can accelerate delivery or application delivery on Kubernetes using DevOps Care. So I've been in the industry for around 4.5 years now, entirely in the DevOps space. So I think I have a pretty good grasp on how most of this stuff works. So let's move forward here. So yeah, just a preface here. Some common Kubernetes stories we hear amongst customers or people in the community. Actually, quick question. Are you having some rendering issues I'm seeing like a black square. So just a preface. Yeah, some common Kubernetes user stories that we hear in the community or amongst some of our customers is that Kubernetes is complex, and organizationally, we don't have the knowledge or resources to leverage the solutions it offers to their full potential. So just because you're using Kubernetes doesn't necessarily mean you're getting all of the benefits it provides. I mean, you can run your applications on it just like a standard Linux host. But if you aren't using like any of the automation or like any of the ingress tooling or stuff like that, then you aren't really getting the full benefit. So another thing we hear is that we currently have some Kubernetes infrastructure and workloads in place, but we don't know how to operationalize and optimize our processes and tooling around open source CNCF technologies. So one of the advantages of using open source CNCF technologies is that it's like standardized, and anybody who interacts with your stack or new DevOps engineers you hire will generally have an understanding of sort of the tooling that you're using. So for example, if you're using Prometheus for monitoring and metrics, most people have at least been exposed to Prometheus, as well as Grafana for sort of visualization of those metrics. Another thing we hear is that we're using Kubernetes to run our workloads, but don't have any automation to support increased deployment frequency and reduce developer friction. So in our DevOps Care solution, we've actually sort of built an automated CI/CD pipeline where you can literally just commit your code to Git, and it automatically takes care of all of the deployments, updating the Kubernetes manifests, recreating the services, stuff like that. So I'll go into that in a little bit more detail later on in this presentation. And then a final point we hear is that sharing access to our clusters securely within our organization or with external parties can be cumbersome and expose security concerns. So we at Mirantis have actually developed a really cool solution to this, and it's called Lens Spaces. And it actually allows you to share your cluster both internally or with external parties without actually giving out your kubeconfig file. Because I'm sure most of you are aware, a Kubernetes cluster with no RBAC roles, just a standard install, if you give your kubeconfig to somebody, that's essentially like giving your root Linux password to anybody, because they can create deployments, create resources, update, delete, basically anything. So that's why sharing your cluster without giving the kubeconfig is a really, really key, powerful, and beneficial feature of Lens Spaces. So I just wanted to give you a little bit of background on sort of the state of the DevOps industry and importance of automation and security to business. So this data is a little bit old now. It's from 2021. It's still applicable though. And I think the numbers speak for themselves here in that you can just see exactly how elite organizations can stay ahead of their competitors and stay on top of the ball when it comes to their sort of DevOps processes and tool chains. I can give you a real world example of this actually. I'm not a TikTok user myself, but I'm sure you're aware of its explosive growth over the past 2 years. YouTube has implemented their competition to this called YouTube Shorts. And Instagram actually did a similar thing with Instagram Reels. So obviously Google and Meta, which owns Instagram, are very elite organizations in the tech space. Their CI/CD and DevOps processes and tooling are definitely very mature compared to their competitors. So in order to deploy, for example, YouTube Shorts on a scale that Google does, serving billions of users, and in order to be able to do it quickly and efficiently, their DevOps tooling and processes are very mature. So this just gives you a rough idea of some metrics that you can use to sort of put or quantify the data into real world numbers. These are also a little bit older numbers. They're from 2020. I'm assuming a lot of them are higher now. So for example, 89% of organizations are currently running Kubernetes. I would not be surprised if this was even higher now at this point. And Kubernetes is becoming as ubiquitous as Java. So I'm sure most of you have installed Java in your day, and it'll say Java installed on 3 billion devices worldwide. Kubernetes is very quickly approaching that point. Not 3 billion, but you get the idea of what I'm saying. And it's becoming totally ubiquitous. So for example, it's even running in certain cars. I know Mercedes-Benz and Microsoft have a partnership in order to deploy clusters in embedded systems. And if you think about a modern car and all the systems and sensors and arrays and all the data that's flowing through it, Kubernetes is actually a really cool solution to the problem of like keeping all your data in one place, networking all your services together locally in an embedded system, of course. And yeah, so this is actually a really important metric too. 51% of developers say building cloud native applications makes them want to find a new job. So I'm sure most of the people on this call have experienced some difficulties deploying cloud native applications, whether it's networking, database configuration, Kubernetes itself, how can you Dockerize your legacy applications, stuff like that. And then 38% of developers claim their work makes them feel extremely burnt out. I know I've been there before. I'm sure a lot of you have as well, because the landscape is just changing so rapidly that it's really hard to stay on top of things. So this is sort of where our solution at Mirantis comes in. We have this product called DevOps Care powered by Lens. And I'll be going into a lot more detail about all of the key components of it. So just our agenda for the rest of this talk will be, I'll show you some of the concepts around DevOps Care, like sort of the theoretical high-level overview. The components that we've settled on for our tool chain. We aren't opinionated on this tool chain. This is just they're just some tools that we've standardized on for our own operational ease. And then I'll show you some tangible value and outcomes that can actually come from using both Lens Spaces and the DevOps Care product suite. And just some quick notes I could say is that it gives you visibility into application health, status, and security posture. You also get increased deployment frequency and reduced developer friction using GitOps CI/CD concepts. So this is actually really important and a really big topic in the industry today, in that you can declaratively define all of your Kubernetes resources, your application configuration, etc., in code. And this is really important because you have the ability to roll back easily. You have a lot of audit capability. For things like security compliance, you could just hand over a Git repo to an auditor and say, hey, look, this is all the software we're running in our production applications, and here is all the code and all the deployment manifests and everything. So it's really easy and useful to use a GitOps CI/CD system in your current tech stack. And then we also have a service mesh, which we actually use Istio for this concept, which is also really powerful and flexible. And it gives you the ability to sort of do blue-green deployments, canary releases, A/B testing, MTLS. There's a lot of really powerful features in Istio. And then I'll be doing a little bit of a demo, and we'll open it up to Q&A after that. So this is just an overview of what DevOps Care actually is. So if I was to put it into words, it would be a prescriptive managed service that leverages SaaS to manage the architecture of cloud native applications on any Kubernetes anywhere. That's quite the mouthful, and it's it uses Lens at the forefront and the center of the product. So when I was talking earlier about securely sharing your clusters without giving out your kube config, we actually use Lens spaces to connect with our customers so that they don't have to share their cluster with us. So we actually don't we don't have to worry about maintaining our kube configs with a bunch of their clusters. They don't have to be anxious about, let's say, us blowing up anything in their cluster. And then some of the components that we actually do as part of our managed service, I mentioned this earlier, was CI/CD with GitOps principles, SRE and monitoring, which we use Prometheus and Grafana for. And we also have a Slack bot that will fire alerts into a Slack channel. So just during business hours, if you get a little notification, it's really easy to just say, oh, hey, our API requests are 404ing frequently. I'm going to go look into that. We have some developer experience solutions too. So Lens actually comes with this really cool feature called dev clusters, where it's just a one-click deploy of an entire Kubernetes cluster that you can use for rapid development and testing. You can even set up an ingress to it so that you can share it with someone over the internet, which is pretty cool too. I touched upon this already, collaboration with Lens spaces, so you can add people to your space and share clusters securely.
Hey, Connor.
And then,
Sorry for interrupting. Can we just reshare the screen again? I think the rendering is pretty bad sometimes. Can you please stop sharing and reshare it? Sure.
Yeah, so we're going with a metrics-driven approach so we can actually tangibly show you, hey, over the past 3 months, your deployment frequency has improved by X amount, or we've helped you remediate X amount of security vulnerabilities. And we're truly agnostic of Kubernetes flavor and distribution and cloud, on-prem, or hybrid. So we have support for Google Autopilot, Amazon AKS, standard GKE, bare metal, K3S, K0S, you name it. We can support it. And that's a pretty cool selling feature of DevOps Care. So this is actually an I see that it did that again. So this is just an overview of our tech stack and the landscape that we provided. So for CI/CD, we use GitHub Actions and Flux. And I just want to point out that we're not opinionated on this tooling. This is just some of the tooling that we've standardized on ourselves internally. But for example, if you use, say, GitLab CI for your CI pipeline, or Google Cloud Build, or Azure DevOps, we're able to adapt our solution and work with you and totally integrate our concepts and theories using your stack as well. So for LMA and capacity management, and for those of you unaware, LMA stands for logging, monitoring, and alerting. We've standardized on Prometheus and Grafana. For our service mesh, we've standardized on Istio. And for security, we use a really powerful tool developed by Aqua Security called Starboard. And it leverages OPA, which is the Open Policy Agent. And you can define a lot of really powerful rules for security integrations. Let's just say, for example, you didn't want your developers deploying applications in the default namespace. You could set up OPA rules really easily to limit them from doing that. So yeah, just go to the next slide there. So this is a little bit of a deeper dive into our CI/CD delivery pipeline. So how we've set it up is GitHub Actions will look for a new commit. For example, if you commit your code, we have it set up so that it'll automatically build and push a new version of a container to a Docker Hub. And we're not opinionated on Docker Hub either. This could be Google Container Registry, GitHub Container Registry, AWS, whatever. And we have a Flux image automation controller that actually watches this registry for new tags that have been pushed by GitHub. And if it sees a new tag has been deployed, it'll actually pull that image down. And then the Flux controller will make a commit in Git automatically. I'll demo this a little bit later to give you guys a little bit of a better understanding, and update the Kubernetes deployment manifest. So as I was saying earlier about GitOps declarative deployment, this is a really, really powerful feature, and something I would like to push a lot of organizations towards if they aren't already doing any of these concepts. So yeah, so if you just want to go to the next slide there. Yeah, so this is our logging, monitoring, and alerting setup. And this is a pretty standard setup across a lot of orgs. We've done a little bit additional setup. So for example, we have Goldilocks, which can do sort of resource and capacity management. But yeah, this is just really standard. So for example, we have Prometheus that'll scrape metrics from exporters, whether that be node exporters, application exporters. You can also write custom metrics and import the Prometheus client libraries into your own applications and expose metrics to Prometheus, which then can be visualized within Grafana. And this is really powerful for if you want, if let's say you have like a problematic function or method in your code, you can instrument that with the Prometheus client library and expose, like, let's just say, oh, this particular like function is giving us a lot of 502 errors or 404s or 403s or whatever it is. You can actually graph that in Prom, and then you'd be able to sort of get a better understanding of your user usage patterns, which cause this type of thing. And also our service mesh provides a lot of this functionality too with Jaeger tracing. So yeah, if you want to go to the next slide there. So security is a really important part of just computing in general, but especially cloud native computing, because most of your services are exposed and communicating over the internet. So I touched upon this earlier in that we use Starboard, and it's really powerful and has a bunch of application and configuration scanning features. So Red Hat actually just released a report yesterday saying that I think it was 53% of all Kubernetes security incidents are caused by either Kubernetes misconfiguration or application misconfiguration. So Starboard actually scans against a predefined set of best practices and tells you where you can improve your configurations or lock down some of your components or service accounts or stuff like that in order to sort of improve your security posture and minimize attack vectors and surfaces. So yeah, if you want to go to the next slide here. Yeah, so the service mesh is a very, very powerful feature of DevOps Care and just, again, cloud native computing in general. So it provides a bunch of really good and cool features like MTLS, for example. And MTLS, for those of you who are unfamiliar, is mutual TLS. So basically what happens is you can see in the two proxies there, so they actually manage and have the SSL certificates on them, and that's where SSL is terminated. So you can have an application that has no SSL at all, and with your Envoy proxy, all of the SSL termination and communication with other Envoy proxies and applications happens without the application knowing about it. So you don't need to worry about configuring certificates for your app or anything like that. It's really powerful. And this proxy is fully automated in the sense of when you deploy a new application, we have Istio sidecar injection enabled. So it'll actually automatically deploy this proxy and set up like all the necessary routing and traffic towards other sort of applications that you've defined in the infrastructure. It's really, really cool. Yeah, if you want to go to the next slide. So what are sort of some of the tangible outcomes if you do end up sort of going down the DevOps Care path? Well, a really, really important one that we love and a lot of our customers love too is lens spaces. So I already touched upon this a couple times, but it allows us to share our clusters securely, both internally and externally without giving out the kubeconfig file. And as I mentioned before, giving someone your kubeconfig file without any RBAC rules defined on a standard cluster is literally like giving out a root password to a Linux server. So you want to usually try to avoid that at all costs. And there's also RBAC roles that can be defined for granular permissions. So within lens spaces, let's just say you have like admins, developer team 1, developer team 2, etc., like front end or back end. You can define cluster roles and cluster role bindings that inherit from lens spaces. So let's say I had a new front end developer and I had a front end team in lens spaces. I add my front end developer to the team, and the underlying cluster can inherit all the roles so that that front-end developer can only actuate on resources that we want front-end developers to actuate on. So they can't create new resources in the back-end namespace, or they can't update deployments in a database or caching namespace, or something like that. That's just an example. So yeah, if you want to go to the next slide here. So yeah, so this is really powerful. And if you don't have visibility and metrics in your app or your current infrastructure, I strongly encourage you to look into this as one of the first things, maybe in parallel with security. And this is just a quick graph to demonstrate some of the features of what Grafana and Prometheus can offer. So Prometheus actually has all of these metrics inside of it, and Grafana just simply renders it. But as you can see, I've just pulled up the core DNS one for a Kubernetes cluster that I had deployed on EKS. And you can quickly see any sort of issues or negative patterns or even positive patterns in your sort of traffic and applications and whatnot. So yeah, go to the next slide here. And so this one is actually really cool too. So this is leveraging the Starboard controller, which I briefly touched upon earlier. So here you can actually see a bunch of CVEs based on their severity and by namespace. And at the bottom, it's kind of hard to see, but at the bottom, it actually provides you a link to the CVE that you can go and visit. And it usually provides remediation steps. Generally, it's just upgrading application libraries and or like closing ports, stuff like that. Yeah, go to the next slide here. And yeah, this is just a screenshot of Prometheus. So I've pulled up the API server request total, and this is actually for the Kubernetes API server itself, the control plane. And you can expose a bunch of different metrics and collect so much data with Prometheus that it's really powerful and amazing for gaining visibility and observability into both your infrastructure and your application side of things. So it's really, really powerful. So yeah, go to the next slide here. And okay, so this is also a really, really cool feature. So this goes back to Starboard, and Starboard is developed by Aqua Security. So what you can actually do is generate HTML reports of all of the CVEs and vulnerabilities and configuration issues for whether that be a node, an application, a pod, a replica set, whatever. You can develop HTML reports, or generate them, sorry, not develop, and share them with your colleagues or security team, or your security team can share them with you and say, hey, look, we scanned your cluster and we found you're running a Redis cache that's a couple years out of date and it has these vulnerabilities. We'd highly recommend that you upgrade it in a reasonable time frame just to avoid attack vectors and hacking and all that, the fun stuff that goes on in the industry today. So yeah, just go to the next slide here. And yes, so Aqua Security has actually done a lot of work developing a Lens extension. And I didn't mention this earlier, but Lens actually has a really powerful extension API. And there's constantly new extensions being developed and worked on by both internal employees at Mirantis as well as external third parties. So for example, Aqua Security developed this one. And this actually gives you the ability to view all of your CVEs and config audit reports. And a config audit report is basically just checking your configuration against a set of best practices and ensuring that you're sort of aware of some of the things that you might not be doing properly. So this allows you to just stay in the Lens interface itself and analyze like, oh, I have like 5 severe CVEs. I might want to deal with that like ASAP type thing. So it's a really powerful feature. And I strongly encourage you, if you don't have Starboard Lens extension or have never used Starboard, I'd highly recommend just sort of poking around and just seeing some of the power and flexibility that it offers for security. So yeah, so just go to the next slide here. And yes, so that sort of finishes our security components. And this is sort of the meat and potatoes of what I really love DevOps care. So GitOps deployments. So basically, you can see in the top little screenshot there, I just edited a main.go file. and I added and committed it with the commit message as 1.0.11 and then pushed it. So basically with that commit message, we have a GitLab or GitHub action pipeline, and it takes the commit message, and after like testing all the code, it'll build a new container image, tag it with that commit message version, push it to the Docker Hub, and then we have a Flux image automation controller that watches the repository on the Docker Hub for new image tags. And when it sees a new image tag, it pulls the image down and updates the configuration in Git, and then does the deployment into the cluster automatically. So the only thing you need to do to get your code from your laptop into a cluster is this one commit message with the version. And I just want to reiterate how very powerful that is, because if you have a bunch of different developers working on a bunch of different microservices, you can quickly and rapidly deploy all of your microservices into the same or different environments with just basic commits. And you can also do it based upon Git tags or different branching strategies. I just did the commit as sort of a visual representation of just how powerful this is. And then in the screenshot below, you can see the customization reconciliation with Flux. So what reconciliation is the Flux controller checks the state of the current state of your cluster and compares it with a Git repo. And when it sees that there's been a change in Git, it reconciles the state into the cluster so that the state of your cluster matches what's declared in Git. And that's why this is a declarative GitOps approach. And it's really powerful because, like I was saying earlier, you know exactly what's running in your cluster just based on Git. So it's really good for auditing, seeing who changed what. Maybe you want to roll back to a commit. There's a lot of really powerful and flexible features here that we're leveraging and taking advantage of to improve application deployment frequency. So yeah, just go to the next slide here. And yeah, this is just a screenshot of the GitHub action pipeline that I set up for building my Golang demo application. So I'll do a live demo of this shortly after we're done discussing the core components here. But yeah, you can see that the commit is EC27. And if you just want to go back to the previous slide there, Avinash. You can see in the first screenshot, the commit is EC27. So yeah, so just it checks the commit hash and everything, and it's all very integrated and trackable. So yeah, so you can go back to the next slide. And yeah, go to the next one too, actually. And yeah, so you can see in the bottom screenshot, the Flux reconciliation. So it's applied revision 887BB. And the Flux bot actually did that commit into my infrastructure repo. So you can see the commit hash at the top right there is 887BB. And the Flux bot, in this commit itself, the Flux bot automatically updated so this is the deployment manifest for my Golang application, and it updated the image tag based upon my commit message. So I didn't even have to go into my infrastructure deployment repo and do anything. Literally, all I had to do was just git commit, and all of our automation takes care of everything else. It's really powerful, and it's also really flexible too. So if you're not comfortable saying have like fully automated deployments, you could do this on like a PR and wait for, say, an engineer's manual approval in order to, say, deploy to production. But then you could also use this to automatically deploy to staging for a rapid feedback loop with QA and testing. So it's really flexible and really powerful, and I want to reiterate that point quite often. So yeah, go to the next slide here. And yeah, again, this is a screenshot from Lens showing that my application has been deployed to 1.0.11. And again, this happened automatically. I'll actually do a live demo showcasing this momentarily. So yeah, just go to the next slide here. And yes, this is the FluxCD lens extension. So this is, I want to say, in beta. It's pretty flexible in that it allows you to see all of the Flux CRDs and like all of your upstream application repos really easily. So I don't know if you guys can see that extremely clearly, but in the top list entry there, it says the repository or the Git the readiness is false. And that's because there's an actual Flux reconciliation happening in place. So as Flux reconciles the state of the cluster in reference to the state in Git, the readiness will be false until the cluster has matched the state in Git. So it's really, really cool and really powerful. And yeah, do you just want to go to the next slide here? Yeah, and this is just a video. I hope you can. Are you able to play the video actually, or no? Yeah, so I did this demo. This is just a quick demo of how we can use the Istio service mesh to shape traffic and route to multiple destinations for both debugging and canary releases. So I've already gone ahead and done the initial Istio setup. And what we have here is a virtual service definition where we have two microservices, reviews v1 and reviews v3. And what we've done is split the traffic 50-50 between the two of them. So if we get our virtual service, you can actually see the rules have been applied, and there is both v1 and v3 with 50% traffic shaping. Now, v3 will render stars for the reviews, and when we refresh our application, which might just take a moment here, we will get requests to each microservice 50% of the time. So it's possible that we could land back on v3 here, or it's also possible that we could land back on v1. So we'll just wait for the page to see what the round robin technical algorithm has done for us, because it's splitting 50-50. If there was more microservices, you could split the traffic in multiple different destinations. And you can see that after a couple requests, we have lost our review stars. So this is actually sending us v1 of the microservice, and v3 was the one with the red review stars. You can also see that we have multiple deployments here, so we could actually shape the traffic even further and split between all three microservices for debugging purposes. So yeah, this is just a quick demo of how we can use Istio to shape traffic and route traffic to multiple versions of microservices. So yeah, so I think that video does a pretty good explanation of sort of some of the features of Istio. There's a lot more features, but that's like a feature I really like to show people, because when you're doing development or testing or even production releases, and let's say you wanted to deploy 2 instances of your application in prod, so you can gather some metrics, and let's say like you want to do A/B testing or blue-green or whatever, you can shape your traffic to say you want 10% of your requests going to your new version just to ensure its stability in production, and then the other 90 are still going back to your old version. It's entirely possible to do it, and you can shape that in any which way. You could have like 50 different versions of the application and send traffic in whatever way you'd want to do that. I don't know why you'd want to do that, but maybe you do, depending on your use cases. And then, yeah, so that brings us to the next slide, which is basically just a live demo that I was going to go through, and then we can go through some Q&A after the fact. So you guys can see my lens here, right? So I'm basically just going to show you a live demo of how the process we ran through in the slides actually works. So let me just comment this, and then bin name. Go. So what I've done is this is just a basic HTTP server that returns this message: hello test, we're on version 1.0.12. So what I can do is git commit and push, and this has pushed it to GitHub Actions, which is currently running a Docker build, and it takes about a minute to run, so it's happening in the background right here. I'm just sharing my lens screen, otherwise I'd jump over to Firefox and actually show you guys. But yeah, just for all intents and purposes, actually, is there a chat here? I could share the link so that you guys can actually see it being pushed. So I will do that. So you'll see 1.0.12 pushed here momentarily. The build is still happening. Actually, my repo is public too, so you guys can actually see the build happening as we speak. Hopefully it doesn't break. Oh, okay, good. That's usually how live demos go, as I'm sure a lot of you are aware. So yeah, so the build has finished. It's green and it has pushed to Docker Hub. So yeah, so if you go to both those links, you can see 1.0.12, and the repository contains 14 tags. So what we're waiting on here is we're actually looking at the image repository CRD for Flux, and it will eventually pick up a 14th tag. You can see right now it just did that. And what that is now doing is in my deployment, I can go to Go Web Server Demo, and you can see it should be happening momentarily. So we have 1.0.11 here, and the reconciliation should be happening very soon. Oh, here we go. 2 seconds ago. Oh, wait. What is going on here? Okay, give me a sec. This is usually how live demos go. I think that it is demo customization. There we go. Okay, so that just took a little bit of a minute, but you can see now 1.0.12 has been deployed in our deployment. And to take it one step further, we could actually go to our service definition here, and we'll use one of the really cool Lens features of port forwarding to your browser. Actually, I'm gonna have to share my browser to show this. So yeah, so you can see this is actually our live version of our application, and you can see it's actually been deployed to 1.0.12. So again, this is a really, really powerful feature of just all I had to do was the single git commit, and it totally deployed our application. It even updated the infrastructure code repository with the 1.0.12 tag. So hopefully the rendering works properly, but I'll refresh here. And yeah, you can see the Flux bot has totally updated the deployment manifest. And that actually works using this. So this looks like a comment, and it is a comment in YAML, but it's a Flux convention, and basically you create a image policy, and this is the name of my image policy, and then this is just the namespace of it. And it where is our code here? I could actually show you guys more. Demo, and image policy. So yeah, so this image policy looks for new tags that are greater than or equal to 1.0.0, and you could set this to whatever you want. Like, let's say you only wanted to deploy patch versions or minor versions or any version that's tagged -dev or RC 1.0. Whatever. This is totally flexible, and you could adapt, or we could help you adapt this to your workflow in pretty much whatever way you wanted to. And yeah, that's probably it for the live demo. I could go into a bit more detail on some of the other components if anyone wants me to. But yeah, I guess we could open it up to Q&A now if anyone has so many questions that they want to ask.
Right. Thank you, Connor, and apologies for any of the technical glitches in between. Please feel free to use the Q&A section in the chat and post any questions. Okay, there's one question in the chat. Do we have like starboard reports integrated with this cluster?
So are you referencing the cluster that I just deployed my demo application into? Because the answer to that is yes. So I've actually generated a starboard report for a node. I just did this prior to the demo. I can actually generate it again just to show you, and then I'll open node report, and it'll open it in my browser here. And now you can see, I see that there's a little bit of rendering issues here, but that's all right. You can see the report itself. So yes, we do have starboard reports integrated with this cluster, and you can scan literally whatever you want, like Redis images, nodes, deployments, configurations, you name it, you can scan it, and it's really powerful. And it also is constantly updated with the latest CVEs that are announced publicly in the industry or 0 days or whatever. So it helps you stay on top of your security posture. Do you use Helm charts? I hope that answers your question. Go cool. Do you use Helm charts with Flux? Yes, the answer is yes. Flux has a CRD called Helm Release, which is really cool. I wish. Sorry about the rendering issues. It's a Firefox thing, but here I'll share again. And so yes, you can do Helm releases in Flux. So I think we have here, if I'm not mistaken, and yes, so Istio-D Helm release. So you can totally manage Helm releases within Flux and pass all of your values in automatically. And it can literally automate the entire deployment of your entire infrastructure with Helm. So all you would need to do is when you're setting up Flux for the first time, and let's say you have like a bunch of Helm releases configured in Git, you just need to create the customization, which I was showing earlier with the flux reconcile command. I'll answer that question in a second. With the flux reconcile command, and it'll reconcile the state in Git and in your cluster. So let's say in Git you have like 100 Helm releases, like you're doing like Cert Manager, I don't know, Istio, Prometheus, Grafana, you name it, all the cool buzzword technologies. It will take all of the Helm definitions and deploy them into your cluster automatically. So if you wanted to lift and shift your cluster from, say, AWS to GCP, totally doable, totally automated. You could probably get it done in like 3 hours if you weren't using any GCP or AWS specific tooling. Or if you want to duplicate your cluster, like let's say, hey, we have a prod cluster where we need to do some testing, we're deploying a new feature, but we don't want to do it in production. We'll just mimic the configuration from prod and just change the name from prod to staging and set up all the necessary like DNS and whatever. If you want to do that, you could do that. You could integrate it with Terraform. Well, not Flux, but you could use Terraform to automate some of those other like components, like the DNS stuff or cloud resources or what have you. And to answer your question about Argo, yeah, that has been talked about internally. We don't currently have enough internal resources to focus on both an Argo and Flux extension, but I will point out the extension API is totally public. So if you wanted to create your own extension or have interest in doing it, or even if you want to open a feature request in the Lens repo because it's open source and on GitHub, you could do that and say, hey, I would really like an Argo CD extension. Would it be possible to sort of investigate it or maybe get some resources allocated to that? But yeah, I don't want to give you a concrete answer, but down the road, there will probably be an Argo CD extension, but I can't give you an accurate timeline on when that would happen. But again, if you have development expertise with TypeScript, then you could totally tackle that if you wanted to. What is Flux?
On to that, it is on the roadmap. It is under consideration. So everything is like centered around lens, and then building in lens extension is a straightforward approach. So it will be considered like in the future in terms of building extension. And moving on to the next question, it is in the Q&A sections. Can you tell us more about like the lens spaces and how the sharing feature works?
Did I miss that one? I see Joachim, I hope I pronounced your name right, regarding the namespace question. Let me answer this namespace question real quick. So the Flux components are deployed in a single namespace, the DevOps Care Flux namespace. But your applications do not need to be deployed in either a single namespace managed by Flux or the Flux namespace. You can deploy them in whatever namespace you want to, and it's just the Flux components that exist in the single namespace. If you wanted to deploy everything in a single namespace, you totally could do that. It's really flexible. But yeah, that's just how we sort of have it set up at the moment. And sorry, Avinash, what were you talking about regarding lens spaces there?
Yeah, there was there are like few questions in the Q&A section. So the first one is, can you tell like more about like the lens spaces, sharing feature works?
Yes. So when you as a cluster operator or admin or whatever have your kube config on your local file system, what you would do is you would create what's called like a team space or a shared team space, and you can use what's called the cluster connect feature in Lens. So basically, let's say you wanted to share your cluster with me. You would create a team space, you would send an invite to my email address or whatever it is, and then I would be added to your team space. Now, how I actually access your cluster without using your kube config is through this agent that we have and the Lens Space team has developed called the board agent. And what this does is it proxies requests to the Kubernetes API from the Lens terminal. So when you're in like Lens and using the Lens terminal and doing direct kubectl commands, it's actually proxying through this tool called the board agent so that we can connect, or anybody who's in the shared space can connect to the cluster securely. By the way, this is all HTTPS and there's no like security implications of this. And yeah, so that's how sort of the cluster sharing feature works. And you can actually define multiple clusters in the same space. So like you could have like development, staging 2, prod, your personal dev clusters, and yeah, anything like that. It's really flexible and really powerful. So
okay. So any suggestions or opinion to use Jenkins against Git actions?
So we have just standardized on that tooling for ourselves. Everyone has an opinion about Jenkins. We can definitely adapt our solution for Jenkins. But we currently don't have internal plans to sort of use Jenkins as like our tooling. But if you as a customer want to use Jenkins, by all means, we can totally work around and adapt our solution to work with Jenkins for sure.
Okay. And with respect to like other questions, I think, do you recommend like to learn cloud native KTS resources like RBAC and PSP, or use Flux to configure it?
Yeah. So to answer that question, I think it's better if you have like at least some understanding of how Kubernetes resources and objects work. Flux doesn't actually configure any RBAC permissions. If I'm reading your question correctly, what you would have to do is actually write the YAML files, like the cluster roles, cluster role bindings, that type of stuff. And you could use Flux to like deploy those resources into the cluster, because you can basically think of Flux like doing kubectl apply automatically in the background against all of your YAML deployment manifests. So if you have like a bunch of RBAC roles and cluster roles defined in your repo, then yeah, Flux will apply those roles to your cluster. I hope that answers your question. So there is no option to use a shared cluster outside Lens. Not that I'm aware of. You might be able to install the board agent separately, or manually, I should say, but the board agent connects to an upstream server, which is managed by us. It uses Keycloak for identity and access management. So I don't know how the access and JSON web tokens would be proxied.
Yeah, so Connor, just to add on to that, right? I think so sharing the cluster without creating additional kubeconfig files for users, where they has to go through intensive onboarding process, it is not possible. It is a unique feature in Lens. For example, like a real scenario is you are working with an operations. We are in an operations team, and there is a 7 going on. And in order to give visibility to a developer access to certain application logs, the operations team can quickly share access to share the cluster to the development team, so they have a quick visibility into the pods, logs, how they are running. Uh, during during the 7 call, it just simplifies how the troubleshooting is done, and as soon as the troubleshooting is complete, the access can be revoked for the development team. Let's say if you have to do this, implement the same scenario without the Lens, then the user has to be onboarded into this production cluster. Like when I say user, it's like the development team, where it just runs out of the existing compliance or existing standards, and makes it much more complex. So just to answer like this question, it is not possible, and if it has to be done outside of Lens, then it has to be like the standard Kubernetes RBAC followed by generating a Kubernetes kubeconfig file for the users.
Secrets in Flux can be done in one of two ways. You can use Bitnami sealed secrets or Mozilla SOPs. Either one works. We've tested and integrated both. So it really just depends on if you as a customer had a preference towards one or the other. I personally like Bitnami sealed secrets myself. It's really easy and flexible to work with, especially in the context of Flux. So you can keep all your secrets stored in Git itself. I think that's sort of where your question is coming from regarding security. But yeah, you can encrypt your secrets and store them in Git, no problem, no concerns, and Flux can totally handle the decryption of it. And actually, when you're using sealed secrets, technically Flux doesn't even decrypt the secret itself. It just actually uses a reference to the secret in the cluster. So it's technically never decrypted by Flux, which is really cool too. I don't know if that's the case for SOPs. I think Flux does actually decrypt SOP secrets, but it's just sort of an implementation detail, and it's not really a big concern. They're both really powerful, and we've used both, and they're both awesome. So I hope that answers your question.
Thank you, Connor.
And sorry, I just want to touch again on Michael. I hope that's how I pronounce your name. Your point regarding sharing clusters outside of Lens. Yeah, so that actually is like one of the selling features of Lens and like Lens Spaces. And like as far as we're aware, there's not many or any other products that have that functionality in it. And again, when I was touching upon like sharing your kube config is like sharing your root password. Yeah, so this is really, really powerful for like if you're an operator or an administrator of a cluster and you want to give your developers access, super easy to share. You can even give like business people who aren't really like comfortable with coding and all that and technology and all that kind of stuff. If they want to poke around, you could easily do that and just set them as a member. So the member role in Lens Spaces is read only. And then there's two other roles, admin and owner. And owner is just the cluster owner. And then admin has read and write access. And you can also define other roles, like I was mentioning, like back end, front end, I don't know, database, like finance. Like you could do anything and use cluster role bindings and user impersonation to totally lock down your cluster if you want. And we could definitely like help you out with that sort of process and like theory and workflow if that was desired.
Okay, thanks, Connor. I think that's all like the questions that we have in the chat and Q&A session. Uh, I think we are good to end the session, and thank you everyone for joining us today. We will be sharing like the slides and then like posting like a quick article like addressing all these Q&As in Mirantis Labs. And if you are subscribed to the Mirantis Labs email, you will be getting a notification with all the necessary information and updates on this talk. And we will be looking forward to join us in the future sessions. Thank you so much. Thanks, everyone.
Take care. Have a good
Connor.
Take care.